Ay, naku. Ah,
Hey everyone, welcome back and let's write some more neat code today. So today let's solve a problem, daily temperatures. We are just given an array of integers which represent temperatures, and we want to return an array answer such that at every single position in answer, it's going to be the same exact size as our temperatures array. And at every single position in answer, we want to know for the
oo
ith day, whatever the temperature was on the ith day, we want to find how many days did it take for us to find a temperature that was greater than the temperature on the ith day. So for example, let's take a look at this temperatures array. We can see there's 8 values in the temperatures array and there's 8 values in the output for
Naalala
each
ko na.
value in the temperatures array. For example, 73. How many days did it take us in this array to the right of 73? How many days did it take us to find a new temperature that was greater than 73? Well, on the exact next day, we found 74, which is greater than 73, so it took us 1 day. So in the first position, we're going to return a 1. What about 74? How many days did it take us to find a new temperature that was greater than it? 75, 1 day later, right? Okay, for 75, how many days did it take?
What?
Hey everyone, welcome back and let's write some more neat code today to find a temperature that was temperatures that never had a temperature greater than them. Look at these last two temperatures. We had a 76, nothing to the right of 76 is greater than it. And of course, the last position, 73, there's no temperatures to the right of it in the first place, so nothing was greater than 73 to the right. So for these ones, we're going to return a default value of 0. So we're going to build an output array. Now, looking at the input, what's the brute force way to do it? Of course, we could do an n squared approach, right? Like for every temperature, we would look through the entire temperature array after it, right? And see, okay, how many days did it take us to find a temperature that was greater than this one, right? And then do the same thing for the next temperature over here. Look through the entire array, see, what's the first day that we could find a greater temperature, and keep doing that. Now, that's going to be big O of
Wanna-try na?
n squared time complexity, but there actually is an easier way to do this problem if we use some extra memory. Now let's just iterate through the input array once going to the right, but we do need to know that, for example, we have to remember the previous temperatures that we looked at. So if we, let's say the previous temperature here was a 73, like in the input example, and then the next temperature was a 74. When we get to this position, we have to somehow remember what was the temperature that came before it, right? Now, obviously, we could use a list for that, or in this case, a stack would be more intuitive because one thing we're going to notice is if we get a temperature greater than it's 74, right, then we're going to say, okay, what was our previous temperature? 73. So this temperature is greater than it, right? So we can keep track of what index this occurred at and what index we're at right now and say, okay, the difference between these indexes was 1, right? We clearly found a temperature, the first temperature, greater than the 73. So then what are we going to do from our stack? Well, then we don't have to remember this anymore, right? We're going to say, okay, we're going to put a 1 in the output and we can pop this from our stack, right? So we're going to do stack.pop. So this will be popped from the stack. Now, when we get to a 75, the exact same thing is going to happen, right? Clearly, we see these temperatures are in increasing order. So we see, okay, one day it took us to get a temperature greater than this. We'll put a 1 in the output, pop this from the stack. And if we just had increasing temperatures, that would be really easy for us, right? But it's not always going to happen where we have increasing temperatures. What happens if we had a 72 that came after it? Well, we would look at this 72 and compare it to the top of the stack, say, okay, this is not greater. So we can't pop from the stack, but we're also going to take this value and add it to the stack. So now we're going to have two values inside of our stack. And what happens if we got another smaller value, 71, right? So far, for none of these values, do they have a temperature to the right of them that's greater, right? So all three of these are going to be on the stack. What are we noticing about our stack? It's going to be in monotonic decreasing order, right? This is a type of stack problem that I have solved on this channel a couple times, but this is more of a beginner-friendly monotonic decreasing stack problem. What this means is that our stack is going to be in decreasing order. That's what monotonic means. It's always in decreasing order. Now, technically, what happens if we got another 71 over here, right? Well, in that case, 71 is not greater than this, so all four of these would be on our stack currently, right? So it's technically not monotonic decreasing order. It could be equal as well, right? We're noticing it's not strictly decreasing. If two values are equal, they're also going to go on the stack. But if we got a greater value, if I got to a 72, right, what am I going to do? Clearly, 72 is greater than the top of our stack, so I pop this one, right? But now we have a new value on the top of our stack. This one is our 72 greater than this? It's not. So our stack is like this now. We looked at our stack, we took this guy out. This is no longer in our stack, but these three values are in our stack. And still, notice how the stack is still in monotonic decreasing order. It's always going to be the case. What happens if instead of a 72, I had a 73? Then of course we'd still pop this 71, and then we'd also want to pop this 72 because now 73 is greater than 72. We pop this, but it's not the case for this one. But if we change this value to a 74, excuse my bad handwriting over here, but if we change this to a 74, then yes, we are going to pop this one as well. So no matter what we do, our stack is always going to be in monotonic decreasing order. If I add a 70 over here, we're not going to pop anything. It's still in decreasing order. So let's just run through a quick simulation. Let me show you how we can get this output in linear time using a stack. So first value 73, we're going to compare it to the top of our stack. Our stack is empty, so we're not going to do anything. We're just going to take this 73, add it to the stack. Next, we're at 74. We're going to compare it to the top of the stack. 74 is greater than 73, right? What index did 73 occur at? At index 0. What index does 74 occur at index 1? So we take the difference, 1 minus 0. So it took us one position to find a value greater than 73, so we can pop 73 from our stack, and then 74 is going to be on the top of our stack now. Now, exact same thing is going to happen with 75, right? 75 is greater than this. The difference between the indexes is 1, so we add a 1 to the output for 74, and we pop 74. Now we're at, and we add 75 to the stack. Next, we get 71. 71 is not greater than the top of our stack, so all we do is add it. We don't update the output in either of those positions. Again, we get a smaller value, 69, so we add it to the stack. We can't pop any of these. 69 is not greater than either of these. Next, we get a 72, right? 72 is greater than 69, right? So we pop 69. What was the difference between the indices? It was 1, so we're going to take in the corresponding output position, which is in this position for 69, we're going to say, okay, there was an index difference of 1. Now we're going to look at the next top of our stack, 71. So the difference between these two is 2. So for 71, we're going to say it took 2 days for us to find a greater temperature than 71. So for this position, we add a 2. So we pop 71 from our stack. Now 72 is not greater than 75, so we still have a hole in our output over here. We never found a greater temperature than 75 yet. And similarly for 72, we have a hole. Next, we get 76 and compare it to the top of our stack. So 76 is greater than 72. We pop 72. The difference, the number of days it took us was just 1 day, so we can add a 1 for 72. And then we look at the next top of our stack. Yes, we finally found a temperature greater than 75. It took us 1, 2, 3, 4 days to do that, so we can add a 4 in the output in the corresponding position over here. And we can pop 75 from our stack. I think I just need one more square over here because we have one last temperature in our input, 73. So we're going to add 73. See, 73 is not greater than 76. So we can't pop that. And now at the end, we have no more temperatures to add, right? We still have 2 temperatures left in our stack. And whatever the default value for the unpopped temperatures is just going to be 0, right? They told us in the description of the problem that if we can't get a greater temperature, we're just going to put 0 for these. So that's how we build the output. You can see it exactly matches the output that they built in the example. And we did that in linear time by using this monotonically decreasing stack in O of n time, O of n memory. So now let's jump into the code. So we are going to have a result or answer array, and it's initially going to be default values of 0 because that's kind of what they tell us. And it's going to be the exact same length as the input array temperatures. I'm also going to have a stack. Remember, this is our extra memory input array temperatures. They tell or answer array, and it's initially going to be default values of 0 because that's kind of what they tell us. And it's going to be the exact same length as the input array temperatures. I'm also going to have a stack. Remember, this is our extra memory. It's going to contain a pair of values. In the drawing example, I only showed that we're adding the temperature, but we're also going to add the index of the temperature so we can calculate the difference, basically calculate the number of days it took us to find a greater temperature. So we're going to be adding 2 values to this stack, a pair of temperature and the index that that temperature occurred at. Next, we're just going to iterate through the temperatures array. We're going to enumerate this, meaning we're going to get the index of it and the value at the same time. It just makes the code a little bit cleaner. I is the index, T is the temperature. First thing we're going to do is see, is our stack empty? And if it is this temperature greater than the temperature on the top of our stack? The top of our stack is index -1 in Python, and the temperature is the first value in that pair, so index 0. And so if this is true, of course we can pop from our stack, right? So stack.pop. So I'm going to call it the stack temperature and the stack index, which we just popped, right? And for this temperature, we want to, in the result output say, okay, whatever the index of this temperature was, stack index, we want to compute the number of days it took us to find a greater temperature. We can do that with I, the current temperature that we're at, minus the index of the temperature that we just popped, and we take the difference of those. That gives us the number of days it took to find a greater temperature, and then we're just adding it to the stack at the corresponding position we want to. And then once that while loop is done, it might execute 0 times, it might execute multiple times. After it's done, then we finally want to append to the stack the temperature that we're currently traversing. So a pair, the T, the temperature value, and the index of that temperature. And once we're done with that, we can go ahead and return our result. The reason we don't have to fill in any extra zeros if our stack is non-empty is because we already initialized our result to be 0. So if we never filled anything in, the default value is automatically going to be 0. So you can see the solution works and is pretty efficient. So I hope this was helpful. If it was,
Huwag mong biyangin tayo ka, ah. Oo, nagsu-support lagi kang wala sa bahay. Ano kung puwede mo namang ibaba na yun kung ano ba? Mag minsan kasi ano yun 'pag ano yun, hindi yung tingnan mo yung ano yan, hindi kung ano lang yung gusto mo bang maging gwardiya? Hindi. Ha? Hindi. Kasi kung seat, sabi lang sa'yo seat lang dun, nakadun ka sa gilid, 'di ba? Anong pinagkaiba nung gwardiya tsaka yung ano, nung gwardiya hindi yung nag-iisip. Ang ginagawa lang nun ano yan, kung seat lang, tumayo ka lang diyan, yan. Yun lang yung gagawin niya. Maghapon yan, nandun, 'di ba? Gusto mong gano'n? Minsan ano yan, i-check mo din yung surround kung ano yung may tutulong mo or ano yan, kung may ano, 'di ba? Ano na, sige. Kasi po ano eh, magagaling pa rin eh. Siyempre ano, tumulong ka na rin natin na i-clear mo yung mga lahat ng dadaanan. Hindi yung naiiwan mo na pa dito. Yun mo kayo ano yan, stress ka. Kung mo yung nasa sa pamaba.